All right, so welcome to three-dimensional geometry, where we are going to find the surface area of pyramids and cones. So just to give you a heads up, the super secret formula that we're going to look at today for the surface area of a regular pyramid is going to look like this. Again, I use SA. It's going to be B plus, and another way to write that is the area of the base plus 1/2 this funny L and a P. Now, we have to know what these things mean. Of course, capital B means the area of the base. Lateral area means everything else. So we're adding something plus everything else. So something plus not something gives you everything. Now, the lateral area, as we are going to see in a moment, is going to be 1/2 what's called slant height. So let's make sure that this slanted L here, is called the slant height. We'll unpack that in just a moment. And of course, the P means perimeter of base. Of the base. Notice that base does not mean bottom, but most of the time with cones and pyramids, bases will be on the bottom just because that's how they stand up, mostly. So by way of introduction, let's look at a few things here. We're going to give the mathematical name of the solid. Well, it is safe to assume in many cases that what we see down here is actually going to be regular. It's a regular. So in this case, I could call this a square pyramid. Because the base is a square. Since the base is a square, that's where it gets its name, or its specific name, and the entire thing is a pyramid. Of course, what makes it a pyramid is that we have that all the lateral sides. The lateral sides don't connect bases. It's not like it goes from this base and connects another base up there. All the lateral sides end up meeting at a point. So that's where the definition comes from. All right, so what kind of figure is the base? And we already mentioned that. The figure of the base is a square. What kind of figure is each lateral face? So we're looking at each of these puppies here. And we see here that they are triangles. If you wanted to argue isosceles triangles, you probably could. The triangles here are sufficient. How many lateral faces does this puppy have? Lateral faces, there are only 4 that go around. 1, 2, 3, and 4. And we just need 3 lateral edges. A key component to being able to survive surface areas of pyramids and cones is that we need to know something called the slant height. So I like to think of the slant height as something that, let's say I have I'm standing on the top of the pyramid and I roll a ball down and it goes all the way down to the middle down here. So the slant height is the height going along this, the height of a lateral area, the lateral face. So rolling the marble down here, for example, until it gets to it's got to be the midpoint also. Because essentially what we're finding, if we look at it from this perspective, is if I look at this triangle right here, you don't have to draw this. If I look at this triangle right here, the slant height is essentially, the height. See, this is the face, so it's the height of that face. It's just leaning up against the wall, okay? It's like taking a ladder and leaning it against the wall. All right, so the question is, how do we find out what that slant height is? There's a couple different ways to approach it. Let me look at it from the perspective of a cross section. If you cut this with your butter knife and go straight through, notice you get this triangle here. That I'm just cutting straight out. And the 12 that's here is the 12 that's here. So L is effectively, we're just ignoring that half of the triangle, and we're just going to use this here to find out what that is. So clearly, we have a right triangle. So we're going to use Pythagorean Theorem, that this part here being 4, because I just cut the 8 in half, and this part here being 12. So I say 4 squared plus 12 squared is equal to L squared. So the height of the triangle here is 12. So that's not the hypotenuse. And then continuing on. So the official slant height of this pyramid right here, the answer is the square root of 160. And when you simplify it, you get 4 radical 10. Good. And here's the setup. 3 squared plus 16 squared equals L squared to find this slant height. So your exact answer is this, because 265 doesn't reduce any further, because 53 times 5, and both of those are prime. So it's actually probably helpful to have this approximated. So we get 16.28. This chart here shows you pretty much the steps that we're going to take. We're going to identify the shape and then calculate the area of the base, because ultimately we need to find area of the base. Then we're going to determine or calculate the slant height. We're going to calculate the perimeter of the base. We're going to substitute L and P, these two here, in to find LA. And then we're going to add up this plus this to get this. So that's your general flow. So let's look at the very first one here. The shape of the base is going to be a square. And the area, or I'll use the capital B for that. B is going to be 7 squared, which is 49. I'll leave out the units for now until we get to the very end, units being square inches. Now, what's nice is that the slant height is given to me already, so there's no work to be done. It's simply 11. And now, perimeter of the base is simply the square going all the way around, so 7, and I see that I have 4 of those, so 4 times 7, and of course the answer is 28. Again, inches, but I'll keep that at the end. Lastly, I'm going to take the or not lastly, but penultimately, I'm going to take in order to find the lateral area, I'm going to substitute in the 11 slant height, and the perimeter being 28. Multiply those together. And I get 154 square inches in this case. So now, lastly, the surface area is going to be B, which we already calculated. There's only one base in this diagram, and that would be 49. And we're going to add it to the 154. So the surface area is going to be 203 square inches. So check your answer here, 132 meters squared for this pyramid here. Now don't you worry, things do get more complicated. So let's take a gander at this next one. The difference between this one and the previous ones is that we are given the height, but not the lateral, I keep saying lateral, not the slant height. So I actually need to take a moment to calculate that when I get to it. So I'm going to start my process exactly the same way here. The shape of the base is a square. And I'm going to say B is equal to 8 squared, so 64 square inches. Now the slant height in this case, I'm going to take a moment just to sketch the reference triangle so that I know what to do. This does not always have to happen, but for now, visually it might be helpful. So here's my height of the pyramid. Here is the slant height, so I'm just connecting the bottoms here, which would be half of this side here. So I get that. Now, some of you quickly note that L has to be 5 because this is a Pythagorean triple. If you have forgotten that, then 3 squared plus 4 squared is equal to L squared, and that'll still give you 5. Okay, so now we have L is 5. The perimeter of the base is straightforward, so 4 times 8, so we have 32. All right, and now the lateral area is going to be 1/2 the 5 times the 32. 16 times 5 is 80. So in the end, we add these two together, 80 plus 64. So surface area is 80 plus 64, so 144 square inches. Okay, now the surface area of a right cone turns out is exactly the same, except that we are going to substitute circular stuff in. The area of the base plus 1/2 PL. But we know that the area of a base is 2 times pi, is pi r squared. Because it's a circle. The base is a circle. We also know that my perimeter of a circle is also called a circumference, so I say 2 pi r. I just substitute in. And the L is still L. No changes there. Okay, now, any of these work. You can use this and just think about it step by step like I've done. You can actually break it down like this, but notice that I can still use the distributive property to factor out, and actually I can simplify here, see the 2's drop out there. And I can pull out a pi and an r. So watch what we end up getting. Pi r times r plus L. So it turns out that the surface area of a cone is pi r times r plus L. So much faster. So the really only thing you need is to make sure you have two variables, the radius and the lateral height. So I'm actually going to, for this, just skip everything and go straight to the super secret formula. So because the surface area is pi r times r plus L. Now, according to the diagram, my radius is 10. So 10 again, and my slant height L is 15. So much faster. So I do like cones. They taste better than pyramids, and they're faster to use. So here is 25 times 10 is 250. So my exact answer is 250 pi, and my units being centimeters squared. And my approximate value, 785.4 centimeters squared.
What if you didn't know this land?
When we are looking at this cone, since we are given L already, so this is my slant height, and this one is my R, I don't need to use this sequence map here just to fill in, because everything is pretty much just substitute in. And so I end up with 33 pi square inches. 103.7 square inches. And depending on what the instructions say, we have our both forms there. All right. So sometimes it's straightforward because they give it to us, the L, they give it to us, but sometimes they don't. So we have to take a moment to calculate. Notice here that if I were to take a cross section, if I take my butter knife and slice through right there, I do end up with this triangle, this triangle right here with a 5, a 12, and now this height, not height, but my hypotenuse, which in this case is going to be my L. So I can take a moment to use Pythagorean Theorem in order to find out the slant height. So, since I'm using Pythagorean Theorem, And I do have to recognize that my hypotenuse is L, so I substitute accordingly. And then I get 5 squared plus 12 squared is equal to L squared. Now, some of you may notice already that a 512 is part of a Pythagorean triple. So if you happen to have that memorized, then don't do the calculation. Just tell me what L is. L is 13. And just to finish it up so you can see where that from whence it comes, 144 equals L squared. And then 169 is equal to L squared, and square root both sides to get positive 13. Of course, mathematically, we get a negative 13, but distance can't be negative when we're measuring. All right, so now we can just substitute straight in. The surface area is going to be pi times r plus L. So pi times r times 5 plus 13. So the exact answer is 90 pi centimeters squared. And then I can find the approximate value by multiplying. 282.7 centimeters squared.